Okay, we wanted to talk about, we talked about tire pressures, setting tire pressures. If you have a crew guy, that's always helpful. If you have to do this yourself, it's a little more difficult. But if you're going to take tire temperatures on your car to validate setup and the conditions that you're dealing with, it's best to do it as soon as you come off the track as possible. And what we have here is a demonstration. This is a Hoosier tire temperature pad that our engineers use at the track when we're taking temperatures for customers. And I just kind of typified one from memory that's kind of typical. Okay, so we want to talk about getting the temperatures across the tire, and to do that, we're going to change views here. And we have an R7 compound tire here, and I want to show you a technique that I've learned over the years that works the best. On a tire, we're going to call this the inside, the middle, and the outside. And as you can see, and on most R compound tires, there's a depth hole, there's a tread depth indicator on the outside, one on the inside, and then there's the center of the tire. So if you get in that region, that's the best place to take the tire temperature on the inside. And this is difficult to do on a closed wheel car when you can't see it, but you just kind of feel where the edge of the tire is. Don't burn yourself, and just go in a little bit. And when you push the needle in, you want to push it in at an angle, and you're trying to get to the base of the tread rubber. Okay, once you get in there, the tire temperature on the display on this barometer is going to drop back, and when it stops, that's the tire temperature. You go to the next position, you do the same thing. You can see even here at room temperature, when I first poke the tire, it says 95, 90, 80, 75, 70. So it's kind of dropped down. And so you go across the tire at those three positions, and then you record those tire temperatures. Next slide. We'll go back to that original slide. Nope. Okay. All right, here we go. I took that temperature pad page and I blew it up, and I just want to show you, this is Road Atlanta, date, car number, blah, blah, blah. I normally write when I'm taking temps what the ambient temperature is and what the track temperature is. Track temperature, you can just usually stick your barometer in the pit lane surface and probe around, and it'll give you a track temperature. You can see on this particular car, we're at Road Atlanta, which is primarily a clockwise track. So the left side tire temperatures are higher than the right sides. And you can see, I usually ask the customer what pressure they started with. In this particular instance, it was 20 PSI all the way around. The hot tire pressures were as follows: 30 in the left front, 31 in the left rear, around to 29 and 28. This profile shows that the car, I would ask this customer, is the car a little loose? Okay, because the higher temperatures are in the rear tires. If it's not, it's just because of weight bias or power or whatever. Okay, but normally this would indicate that the car is just a little bit loose, because as you can see on the left rear, we're 225 inside, 220 in the middle, 200 on the outside. And these are normal, acceptable spreads when you're running radial tires. So, that's just a demonstration of a typical tire temperature profile at Road Atlanta.
So Bruce, if you can, let's just talk about the generic there, which is, cars with negative camber, which is going to be the standard on all your tires, right? For a road course car, you're going to expect to see highest on the inside, medium in the middle, and lowest temperature on the outside of the tire.
Yes.
Okay.
Yep. And that's due to camber, obviously, and air pressure all combined to give you that temperature spread. I just a simple tip. If you're track day, you're doing track day events, you're normally doing relatively short sessions. Okay, as you evolve through your driving career, driving experience, you may evolve into running enduros. Okay, so to optimize tire wear, you might want to reduce that temperature spread so you get more even wear across the tire. You're giving up a little bit of performance, but it's an endurance race. Okay, so you want to maximize tire life, so you might stand those tires up a little bit, you know, based on the profile you read on the tire temperatures.
Yeah, nothing I would say would remind nothing is really set in stone, nor is it forever, right? So as you go to a different track, as your vehicle evolves, as you evolve as a driver, these things change. So having a standardized process and a way to do it and continue to do it, whether it's pressure or temperature, you'll find that, you know, it's all of the details in racing. You've probably heard people say that before, and this is one of those details that you need to be consistent with. And it is much easier if you have a buddy help you, you know, so you don't jump out of the car and try to do it, but certainly doing it consistently.
You know, and going back to the consistency or your process, you know, this is just a tire pressure gauge that I happen to use. It's kind of on the expensive side, but it calibrates every time I turn it on, and it reads air density, and it reads humidity, and it adjusts so that the pressures are accurate. Okay. A lot of times in the field, we'll find a lot of our track side service people have a calibration device that you can take your gauge over and check calibration. And, you know, I often find when somebody's deviating from air pressure and they say, well, you say I should be running 20, but I'm running 18, and that just seems to be where I need to be. I found that their tire pressure gauge is off 2 pounds. Okay. So they actually hit the number, the optimum number, but they were getting a different reading. So, and pyrometers, generally, the easiest way to calibrate your pyrometer is to boil some water and stick the probe in there and see if it reads 212. I mean, that's the simple way. A lot of tire pyrometers are not adjustable, but most of the digitals are usually accurate for a long time.
You know, well, we're on the tire probe. I saw the question come across, and we mentioned this in the slide. You know, probe type is best. The challenge with an infrared pyrometer is you get a lot of brake heat interference, a lot of vehicle heat interference, and they tend to not. It just tends to not function effectively.
Infrared pyrometers are great for taking tire temperatures. I mean, for taking track temperatures. Yeah. Okay, but tire temperatures really need to be taken with a probe needle type thermocouple. And, you know, and once again, a lot of times in the field, you know, I'll take somebody's temperatures and they'll say, wow, you're a lot higher than what we were getting before. And that's when we go into what we demonstrated earlier with Probe 101. You know, if you stick that tire like I showed you, you're probably going to get a more accurate reading. A lot of times I find that people are checking tire temperature, they're sticking the needle in vertically like this and not really penetrating down into the tire to get the base rubber temperature. So, you know, sticking a tire like that, not the right way. Digging the needle down in.
Not too far.
Yeah. Well, that's why you do it at an angle. It's a lot safer. You know, you're not going to penetrate through the overwrap and, you know, compromise the carcass of the tire and develop a leak. So if you go in at an angle, you'll feel much better where the base of the tread rubber is.
And something, let me point out something about, I think this slide's great because it kind of brings together a few things we've talked about so far. One is the, like, sort of documenting where you are right now. Obviously, to take pyrometer temperatures, I think realistically you need to have a friend help you, because by the time you get out of the car and start taking them, it's going to be, you know, the temperature is going to bleed off to the extent. And I think that's actually one of the things I've heard about the infrared pyrometers is that the surface cools so quickly that it's very hard. In addition to those interference issues, it's very hard to get the accurate temperatures, right? So when we look at this document that you've got here, the temperature and pressure doc, one of the things I want to point out to people is look at the starting pressures on this particular example where it's 20 PSI all the way around. But for Road Atlanta, which is primarily a clockwise course, you've got, each tire is at a different number and they are staggered, right? So if your goal was to come in with your tires at 30 PSI all the way around, your starting pressures would actually have to be something more like, 20 in the left front, 29 in the left rear, 21 or 22 maybe in the right front, and then maybe 20.5 or 21 in the right rear. So the benefit to writing this stuff down is that the next time you come to the track or the next session, you can dial in those tire pressures to be exactly where you want. And I'll just say, in my own experience racing Spec Miata, I've got a binder that has basically one sheet for every session, and it's got some of these same details on it. And when we go to, say, Mazda Raceway Laguna Seca, which is a counterclockwise course, versus going to Sonoma Raceway, which is a clockwise course, each tire is going to have a different starting PSI to get to where our targets are, whether we want them to be square or we want them to be staggered in some way. So, it can be a little bit tedious sometimes to keep some of these records, but if you care about consistency and performance and what this webinar is all about, getting the most out of your tires, there's only so many things you can change about the tire, and pressure is one of those key ones. So keeping some documentation like this is a great way to be able to dial it straight away every time you come to the track.
Well said.